3, 2, 1. Booster ignition.
From launch
Humanity's next great voyage begins.
to flight
We just went sci-fi. This has, it just looks unreal.
to splashdown
From the pages of Jules Verne to a modern-day mission to the moon, a new chapter of the exploration of our celestial neighbor is complete. Integrity's astronauts back on Earth.
The Artemis II mission was seen as a resounding success for NASA.
Thank you for showing us the moon again. Thank you for showing us planet Earth again. And thank you for contributing to the greatest adventure in human history.
But while the Artemis II mission was in flight, and even before it launched, pieces of the Artemis III mission have been slowly coming together.
We've talked a lot about the muscle memory, and with this mission, we'll really demonstrate our ability to support the increasing mission cadence.
But there have been many questions about the Artemis III mission ever since NASA Administrator Jared Isaacman announced it would be a mission in Earth orbit. Questions about timing.
I think, again, next 69 days, we owe it to everyone to describe what Artemis 3 is going to look like.
Questions about orbital parameters.
We do have a request for information out to both SpaceX and Blue Origin to tell us what they think is achievable by 2027. And based on that feedback, we'll use it for ultimately crew selection, but making a determination of do we even need to use our upper stage in this regard.
And questions about hardware, from the landers to the spacesuits to the Space Launch System rocket itself. We traveled from Orlando to Houston and back again to learn all about the Artemis III mission and, of course, to meet the crew themselves.
Mission Specialist Andre Douglas. Mission Specialist Colonel Frank Rubio. Now on to our pilot, Luca Parmitano. Artemis 3 Commander Randy Bresnik.
The big unveiling at the Johnson Space Center in Houston, Texas on June 9th helped give us many of those answers. Let's start with the crew themselves. The mission is led by NASA astronaut Randy Bresnik, who will be making his third flight to space. He last flew as a member of the Soyuz MS-05 mission in 2017. Since that mission, he has been working as an assistant to the chief of the astronaut office for exploration. That made him a go-between between the astronaut office and the Human Landing System program. He began his remarks by thanking his family as well as those at NASA who made this moment possible.
The opportunity to represent the astronaut corps and every single person in NASA, ESA, our industry partners, our international partners, whose blood, sweat, and tears, okay, hopefully not blood, and very few tears, but their collective effort will lift all of us up on that SLS rocket when we hit launch day and carry us through the mission.
Joining Bresnik is another test pilot, Italian astronaut Luca Parmitano, serving as the Artemis III pilot.
He has been tested. During a spacewalk early in his career, his helmet began to fill with water, a dangerous situation by any standard. He handled it with calm and clarity and brought himself back safely. That tells you more about an astronaut than any CV ever could. Luca is precise, composed, and determined. Yes, I'm sure he brings a touch of Italian ease to the cockpit. He is exactly the right person for this role, and he is ready.
NASA astronaut Frank Rubio is making his second trip to space as one of the mission's specialists. He holds the record for the single longest spaceflight by an American astronaut after a Soyuz issue prevented him and his crew from coming home on time.
What an incredible blessing and an honor it is to be standing here representing all of you. And I'd just like to take a quick second to say thank you, first and foremost to my wife and our 4 amazing kids. Thank you for your sense of adventure and your resiliency. You guys have made all of this possible.
Rounding out the mission is the lone spaceflight rookie and NASA astronaut Andre Douglas. He will serve as Mission Specialist 2. Douglas previously served as the backup astronaut on the Artemis II mission and was also part of the closeout crew, one of the team members who was among the final people to see the flight crew in person before launch. He described what it was like when he and the others found out they were going to be a crew.
There was a random meeting that popped up on our calendars one day, and it said some weird title that didn't make sense. And I was thinking like, oh, maybe this is something. So we all went to the meeting, and then I saw all the guys, and the chief just said, "Hey guys, look around. This is your Artemis 3 crew." We're all like, "All right, like this is it, right?" So it was Scott Tingle. He's our current chief, and we all kind of hugged and like cheered, and it was nice. It was really nice to be able to do that.
So that's just a taste of the crew of Artemis 3. Now let's shift from the crew to the hardware. Starting with the launch infrastructure for the Space Launch System rocket, the Mobile Launcher 1 began rolling back on April 16th. It finished heading into the VAB the morning of April 17th. This was much faster than in the aftermath of the Artemis 1 launch. NASA's Sean Quinn says that was due to a lot of work being put in to shore up the ML1.
Yeah, for Artemis 2, our ground system performed magnificently. We brought on a new hydrogen sphere, 1.4 million gallons, so you add that to the other sphere. We still use both, and the new sphere and all the cryogenic hardware worked great. We had to make some modifications to our environmental control systems of the pad. All those modifications worked great. We, so during the launch countdown, we took very few non-conformances on the ground system themselves. And during the, as you know, during the terminal point in our launch countdown, not a single hit. And we didn't have to talk much about ground systems at all. So again, the lessons learned from Artemis 1 paid off during our launch countdown. We did receive quite a bit of damage to the mobile launcher during the Artemis 1 launch. And so, we looked at the damage and we modeled, we updated our models, and then we we hardened the ML, if you will, in various places where we had the most damage, and especially critical systems.
Like the elevator?
Yep, we reinforced the elevator, did quite a bit of structural changes to the interior of the elevator shaft to reinforce it. And I'm happy to say that one elevator is almost up and the second one is going to be up very soon. And so, after Artemis 1, there was a lot of reasons for us to stay at the launch pad. And for one, one of the things that did not work in Artemis 1 was the pad and the mobile launcher washdown systems. And that happened because we lost GN2, the gaseous nitrogen, to the mobile launcher, so we couldn't turn the washdown on when we wanted to. And the washdowns are used to clean the SRB residue off immediately after launch. Well, we addressed those issues for Artemis 2, and the washdown came on right after launch like it was supposed to. And so we were able to get the the mobile launcher cleaned off fairly quickly, and therefore we didn't have to replace all that tubing. If you recall, we had thousands of feet of high pressure gas tubing that we had to replace on the mobile launcher itself. And I'm not aware of any tubing that we're going to have to replace for this time. So the hardening that we did, some of the ablative coatings we put on it paid off. The structural reinforcements of the elevator paid off. We banded some of our critical electrical cabinets with steel bands so that the doors didn't open. All that worked. We did have some damage. The blast doors on the zero deck worked perfectly. Mm-hmm. They stayed shut just like they were supposed to. And that's the 0 to 30 feet is where we have the biggest plume loads. We call it turn flow. And so we spent a lot of time reinforcing those levels. On the levels going up the mobile launcher, some of the doors did open, but they did not cause, any significant damage. So all in all, the mobile launcher fared much better. I'll put it this way. So the engineering team at KSC said, well, if damage on Artemis 1 was a 10, Artemis 2 is probably about a 3. Wow. And coming from our very conservative engineering team, that's music to a program manager's ears, right?
One element that will require some extra work before the Artemis 3 launch is the flame hole of the mobile launcher.
We did lose some panels on the side walls of the flame hole. That was not expected. And we're currently doing the analysis. It could be, the bolts themselves may need to be strengthened or changed. We're still trying to figure it out, but we will. And we don't think it's going to constrain our rollback. And any strengthening or replacement of those bolts will be done in the VAB.
Moving to the rocket itself, the aft segments of the twin solid rocket boosters left Northrop Grumman facilities in Utah in the midst of the Artemis 2 mission. They are now in the rotation, processing, and surge facility. As for the rest of the boosters, Those arrived in Florida on rail on May 8th. Back in 2024, ahead of the booster processing for the Artemis II mission, we caught up with Jacob's booster flow manager, Heather Moss, to learn more about what work happens in this building.
For the aft assembly, what we would do is pull the segment in. On rail car, we remove the cover. We go ahead and crawl into the center of the propellant, inspect that, then we hook up our two 200-ton facility cranes, what we call a breakover, go from horizontal to vertical. We bring it over and mate it to the aft skirt, and then mate the exit cone, which is the nozzle where the flame comes out, here in the build-up stands, and then we start adding instrumentation and that type of stuff to process and be ready for stacking.
Coming back to 2026, on April 20th, the top 4/5 of the Space Launch System rocket core stage rolled out of the Michoud Assembly Facility in New Orleans and onto the Pegasus barge. A week later, on April 28th, the core stage emerged again, this time at the Kennedy Space Center in Florida. In less than 3 hours, it was inside the vehicle assembly building.
So what we'll be doing with the core stage, first this week we'll be lifting it up and over into the high bay to get it integrated with the engine section. After that, the engineers will be checking it out, getting it all prepped before it gets turned over to operations in a high bay 3 and integrated with the boosters and the rest of the vehicle for Artemis 3.
The reason only 4/5 of the rocket was unloaded at Kennedy was because the engine section and the 4 RS-25s will be installed inside High Bay 2. The engines are currently being stored at the Stennis Space Center in Mississippi and will be shipped to Florida when Exploration Ground Systems is ready to receive them. The key difference between Artemis 3 and the first 2 missions concerns the SLS rocket's upper stage. Unlike Artemis 1 and 2, NASA won't use its third and final ICPS, or Interim Cryogenic Propulsion Stage, for this mission. Only 3 of these were ordered by NASA, since the agency originally intended to switch to the Exploration Upper Stage, or EUS, beginning with Artemis 4. But under the Isaacman administration, those plans, along with the EUS, were scrapped. At the same time, NASA decided to pivot the Artemis 3 mission from a moon landing to an Earth-orbiting mission a la Apollo 9. Confirmation came in a May 13th press release in which NASA announced that instead of the ICPS, the rocket would feature what's called a spacer. In essence, it's a barrel section with rings designed to match the size and shape of the ICPS, but without a propulsion element.
Design and fabrication of a spacer that will replace the upper stage on Artemis 3, because we're flying in low Earth orbit, is already in fabrication at NASA's Marshall Space Flight Center in Alabama.
As for the Orion spacecraft, we spoke with NASA's Orion program manager, Howard Hugh, about the vehicle's status about a day before the Artemis II launch.
The crew module is going through its final paces. We're going to put the heat shield on this month. That's really the most significant piece of hardware that we have left to do in terms of getting on the crew module. And then it's all testing. It's all final checkouts, testing, integrated system testing on the crew module, and then we'll stack on top of the service module. Then more testing is going to happen, and the closeout of those activities will take a little bit of time, but it's going through its paces, and it's going very well.
Meanwhile, Kirk Shireman, Lockheed Martin's vice president of its lunar exploration program, talked about readying Orion for flying this low Earth orbit version of Artemis 3.
First of all, we're the chase vehicle in those scenarios with SpaceX and with Blue Origin. And so how it handles as we're going is directly analogous to what will happen with those vehicles. So it's really, really good information for that. We're already working with SpaceX. Of course, the scenario for Artemis 3 always was for us to dock the Starship. That's actually fairly long in development. For us to dock directly with Blue is new. It wasn't the plan before. So we're just starting that I'll call it integration with Blue Origin. It's pretty much at its infancy, but they both have docking mechanism. They were both intending to dock. I don't see any big problems in our future here. It'll just take some work to go make sure we get it all correct.
Many of the biggest questions concerning Artemis 3 involve SpaceX's Starship and Blue Origin's Blue Moon Mark II. These are the spacecraft from the 2 contractors within the Human Landing System, or HLS program. The pair were under a task order to submit their proposals for the mission during April, and then the HLS program would work with the Orion team to flesh out the mission. NASA's Artemis program manager, Jeremy Parsons, described the flow of the Artemis 3 mission as it now exists.
It will begin with the launch of Blue Origin's lander test article, which can loiter up into space for up to 90 days. This gives us flexibility to launch our crew of 4 in Orion on the powerful Space Launch System launched from Kennedy Space Center in Florida. The crew will fly their journey in low Earth orbit on a circular trajectory around Earth. Orion and the Blue Origin lander design will rendezvous in space, spending about 2 days in docked operations, conducting test technology demonstrations, including inside of Blue Origin spacecraft. More importantly, we intend to dock, perform integrated stack control, have crew cross the hatch, operate the lander, and get critical test of the life support systems that can only be done in space. This gives our teams key information on systems the lunar lander crew will depend on in an environment close to home versus 4+ days away around the moon. After docked operations, Orion will detach and await Starship. SpaceX's Starship lander test article will launch and meet up with Orion and our crew. Orion and Starship will dock, be connected together for about a day before the crew transitions to preparations for returning home, splashing down in the Pacific Ocean to a waiting recovery team made up of the US Navy and NASA. In total, we expect the mission to last around 2 weeks. This mission is deliberately designed to take calculated risk so that future crews will be safer and ultimately successful when we put boots on the lunar surface.
Following the explosion at Launch Complex 36 last month, Blue Origin's John Caloris says they're working to recover at Launch Complex 36A while construction on 36B continues. While he didn't specify from which pad the mission would launch, he did discuss the development of the version of the Blue Moon that will fly on the Artemis 3 mission. It's neither a Blue Moon Mark 1 cargo lander nor truly a Blue Moon Mark 2, but rather something in between.
Artemis 3 is a major step that fills important objectives prior to our uncrewed landing on the moon in 2028, followed by our landing of astronauts that same year. On this mission, NASA and Blue Origin will demonstrate rendezvous, docking, hatch operations, ingress, and life support systems in low Earth orbit. This will allow the crew to gain familiarity with our lunar crew module and even practice operations such as suit donning in zero gravity. Manufacturing is well underway on the Artemis 3 Mark II lunar crew module, our storable reaction control system, our docking systems, and our environmental control and life support system. Our factories are running around-the-clock shifts in a responsible manner. Our vertical integration capabilities continue to produce hardware that feeds the production floor. We work very closely with NASA on engineering and testing support with more to come. We expect to complete the vehicle for Artemis 3 and be ready for launch in 2027.
One thing that Caloris didn't mention regarding the spacecraft for Artemis 3 is the BE-7 main propulsion system. HLS program manager Steve Creech explains.
What you're going to see is not a full lander. What they're going to fly is a crew cabin off of Mark II, and then they're going to have basically a mass simulator for the rest of the stage to simulate what the lander will be coming back from the moon. And so it'll have storable propellants, but it will not have the LOX hydrogen cryo propellants that the eventual lander has. So it's really first version of the crew cabin, but sort of a unique test article. It will have storable RCS kind of propellant. It will not have a main engine. It will not have the LOX hydrogen, the BE-7 engines or LOX and hydrogen. It'll all be basically their in-space storable propulsion that they'll use for the Mark II.
Meanwhile, on the SpaceX side, the Starship that will dock with Orion won't be this final HLS version shared in an earlier rendering by NASA.
It's basically going to be a version 3 Starship off the line that we'll add a docking adapter to, but we'll also be working through all the flight rules, all the engineering of being able to integrate with Orion and actually do that docking.
Ahead of the Artemis 2 mission, HLS Deputy Program Manager Ken Shinaki noted that both companies developed medium fidelity mock-ups of the habitation portions of the landers to help train future crews.
Each of our providers is required to have a mock-up of the fidelity of their crew cabin and of their crew quarters. And so we have received a Blue Origin mid-fidelity mock-up that's currently at Johnson Building 9 that we can do some human loop testing in. And we have, for SpaceX, they are building their first engineering model of the crew cabin. So it is building off of engineering drawings. It's of similar construction standards as from flight, and it'll be a full crew cabin, including the ecosystem and any crew cabin, crew quarters, crew interface, and the like. So it's going to be really pretty good, and that has begun at Boca Chica.
And luckily, the Artemis 3 crew isn't starting from scratch when it comes to learning all about the landers.
It's interesting, though, the commander, Randy Bresnik, comrade, has been working with us, and specifically the lander, really closely for several years. So we have a close relationship with our commander. He's well aware of both Blue Origin and SpaceX and what they've been working on. So it's going to be a great crew to work with. I'm sure the rest of them that I don't know as well that haven't been working with us will be great. But having a commander that is so familiar with what we've been doing for years, I think is going to be a real advantage.
As for the spacesuits, Parsons explains those will be tested 2 ways before NASA needs them for an Artemis 4 moon landing.
We are going to fly the spacesuit aboard the International Space Station to check it out in 2027, and we will perform hardware interface checkouts on at least 1 lander in a spacesuit during Artemis 3.
Ahead of the Artemis 2 launch, we also spoke with Axiom Space's Tammy Radford, who described what the testing work is like.
We're going through our critical design review right now, and we are starting our Class 1 flight production. So in addition to that, I'll say in parallel, we're doing a lot of testing, right? We have test units that we have crew from NASA coming and getting in our suit and running through tests at the Neutral Buoyancy Lab and Argos facilities. And we're also having some of our engineers in the suit as well to kind of get that feedback and work on design iterations before going into flight builds.
So as you can see, there's lots of moving pieces to the Artemis 3 mission, both figuratively and quite literally, and you can count on Spaceflight Now to follow it from now through launch, the multiple launches, and the big splashdown. Reporting from the Johnson Space Center in Houston, Texas, Will Robinson Smith for Spaceflight Now.